All right, let's dive right into this. If you've ever looked at a thriving reef aquarium and just marveled at those vibrant corals, there's a good chance you've also felt a little intimidated by what it actually takes to keep them alive. The endless array of testing kits, the little glass vials, the chemical bottles, it can all feel a bit like you've stumbled into a mad scientist's laboratory. But here's the truth. Beneath all of that intimidating equipment, water chemistry is really just the hidden foundation for coral health. So today, in this explainer, we're going to totally demystify this invisible world. We're going to look at the exact water parameters you need to track, but not as a bunch of random, stressful numbers in a chemistry set. Instead, think of them as an invisible team roster, where every single player has a very specific job to do to keep your corals absolutely thriving.
So here's our quick roadmap for the explainer today. First up, we'll cover the hidden foundation. Second, salinity and alkalinity. Third, calcium and magnesium. Fourth, we'll look at the chemistry balancing act. And finally, we'll wrap up with mastering tank maintenance.
Okay, kicking things off with Section 1, the hidden foundation, the invisible team roster for coral health.
Underneath all that complex gear we just talked about, your reef relies entirely on a foundational crew of measurable players. If you want your corals to build incredibly strong skeletons and show off brilliant colors, you really don't need a degree in marine biology. You just need to understand this core lineup. And honestly, it comes down to just 4 key parameters: salinity, alkalinity, calcium, and magnesium. Each one of these plays a highly distinct role in how corals build and maintain their calcium carbonate skeletons. They're definitely not independent variables. They're a tight-knit team working around the clock in your tank.
Moving right along to Section 2, salinity and alkalinity, the base and the buffer. First up on the roster is salinity. Simply put, this is your aquarium's salt concentration. Think of it as the absolute bedrock of the tank. Why? Because most marine organisms, including all your corals and invertebrates, rely entirely on a stable salinity to regulate their internal fluids and basically just maintain their normal biological functions. If this parameter starts to drift too high or too low, your corals are going to immediately show you they're stressed. You're going to see it really quickly, usually as slowed growth or just incredibly poor coloration. To put that into perspective, for most aquarists, the absolute sweet spot is a specific gravity right between 1.025 and 1.026. Depending on your local convention, this is the consistent baseline value you want to aim for. But the really crucial takeaway here? You want to prioritize overall stability rather than chasing tiny, microscopic daily fluctuations. Just pick your target in this range and focus on keeping it rock steady.
All right. Our next key player is alkalinity, which you'll usually see measured in dKH or sometimes MEQ/L. Alkalinity acts as the water's buffering capacity. Basically, it represents your tank's ability to resist swings in pH. And for reef tanks, this is a huge deal because calcifying organisms actively consume carbonate and bicarbonate as they do the hard work of forming those calcium carbonate skeletons. So, as your corals grow, they are quite literally chewing through this buffer.
To maintain a nice, steady environment, the typical reef keeper target range sits right between 7 and 12 dKH. Keeping your alkalinity somewhere in this mid-range provides a super reliable environment. It gives your corals exactly the raw materials they need to consume without completely exhausting the tank's ability to fight off those dangerous pH swings.
But be warned, falling out of that ideal range is absolutely a double-edged sword. When your alkalinity drops too low, your corals will literally struggle to build their skeletons, simply because the raw materials aren't there anymore. On the flip side, when it swings too high, or worse, swings rapidly, it causes massive instability and triggers unintended chemistry shifts throughout the entire tank. So yeah, steady buffering is absolutely vital.
Let's move to Section 3, calcium and magnesium, the builder and the assistant.
Now that we've got our base and our buffer locked in, we need our builder. Calcium is the heavy lifter. It's the major building block required for calcium carbonate skeleton formation, and it works completely hand in hand with alkalinity. Here's the catch, though. Even if your alkalinity is perfect, if your calcium drops too low, it's going to severely limit calcification. Calcium gets actively consumed over time as corals grow. That means it requires periodic monitoring and regular dosing, especially if you're running a system with highly active small polyp stony corals, SBS corals, or if you just have a really high bioload in general.
Next up is magnesium, and honestly, this one is fascinating. Magnesium doesn't actually build the skeleton directly. Instead, it regulates exactly how calcium carbonate forms in the seawater. Its main job is preventing unwanted precipitation events. What does that mean for you?
Well, when your magnesium drops down too low, calcium and alkalinity become much harder to maintain. The chemistry starts to drift, and those precipitation events can actually rip calcium and carbonate right out of the water column, making them completely useless and unavailable to your corals.
Because of this, experienced aquarists will literally refer to magnesium as the stability assistant. It's not the direct builder, it's the chemical glue keeping the rest of the show running smoothly. Without this invisible assistant, the builder and the buffer simply cannot do their jobs efficiently. So to keep this assistant happily doing its job, our target range sits at 1250 to 1350 parts per million. Hobbyists generally target this specific pocket to make sure the tank's demand stays perfectly balanced. By keeping a magnesium right here, you can confidently tweak your other elements based on your test results, knowing those nasty precipitation events are kept completely in check.
Which brings us to Section 4, the Chemistry Balancing Act, how all these parameters actually work together.
As you've probably guessed, these 4 parameters are fundamentally linked. They have to work synergistically. For example, if you decide to raise your alkalinity but completely ignore the calcium demand, letting that calcium fall out of range, well, you're still going to end up with slow coral growth. Or think about what happens if your magnesium is inadequate. Any effort you put into correcting your alkalinity and calcium will be way less efficient because of that increased precipitation risk we talked about. The chemistry literally falls right out of the water column. You simply cannot balance one element without considering the others.
Finally, let's wrap up with Section 5, Mastering Tank Maintenance. Consistency over perfection.
So how do we actually manage all of this in the real world without losing our minds? Experienced reef keepers rely on a simple 3-step maintenance approach. Step 1. Frequent small checks. Don't wait until things look terrible to test your water. Step 2. Consistent dosing strategies. And Step 3. Careful evaporation top-offs. Remember, salinity is incredibly sensitive to evaporation. Topping off your tank, often by using reverse osmosis or deionized water, is an absolutely critical step to prevent that dangerous salinity drift we highlighted earlier.
But if you take nothing else away from this explainer, remember the golden rule of maintenance. Focus on trends, not chasing numbers. It is so incredibly tempting to get a test result that looks just a little bit off and immediately dump a bunch of chemicals into the tank to fix it. Don't do that. Regular testing followed by very small, incremental adjustments is vastly safer for your corals than reacting to a big swing based on one single test. You want to smoothly guide your chemistry, not jolt it.
Which leaves us with one final question to think about. Are you chasing perfect numbers, or are you building stable consistency? By mastering these 4 foundational elements, salinity, alkalinity, calcium, and magnesium, your corals will naturally thrive. But remember, this is really just the beginning of the journey. Once your foundation is rock solid, what other invisible elements, like nutrients or trace minerals, are waiting to be balanced? Thanks for joining me on this explainer, and keep focusing on that stability.